back to Bytes of Pi. Today we're going to be covering an introduction to arrays. This is our first step into dealing with collections in Java. Let's start off with definitions. An array is a list of values in a particular order. So as you can see, here is an approximation of an array, and they have all these values in a particular order. The index is a position a value is listed in that list. So the indexes are right here. They tell you position 0, position 1, all the way up to 9. For Java, you'll notice something different. I don't start with number 1 like normal humans would do. I start with 0. So whenever I'm accessing a position in a Java array, it'll start with the index 0. So I will say the first value is at position 0, the next one's at position 1, and so on all the way to 9. So here's an array of 10 values, but it goes from index 0 to 9. So let's get into actual Java. Arrays are objects, so declaring and instantiating them are like other objects. So if you remember how objects are instantiated, they're very similar. So this will tell me, this creating an array of a type is simply saying that type and open and close the straight brackets. We've been dealing with curly braces up till now. For arrays, we identify an array with straight brackets, so that I can tell that this is going to be an integer array. Now, I just declared it. I haven't created it yet. If I want, like an object, if I want to create a new array, I have to use the new keyword. So you notice when I hit new, automatically it created carved off a chunk of memory in space for 10 values, set it at address location 162, and my variable is pointing to that address location. So my variable points to where the array is in memory. And notice, because it's a primitive, an integer primitive, it automatically set all the values to 0. Okay, so now I have an array of 10 zeros. Now I want to set position 3 to 50. So the syntax for that would be is my variable at position 3, so you do open straight bracket, the position you want to access, and close bracket, and set that to 50 or to whatever you want. So anytime I want to access members in an array, I will use this nomenclature, this type of syntax, where I say variable open the index I want to access, and then closing that brace. Now you can get kind of creative with this. So here's a couple more examples of using this. So up till now, here's what's happened in code. I've created a variable called mylist. At position 162, I've carved off 10 members in space. I've already set position 2 to 4, and I've set position 3 to 5. Now I want to add, maybe I want to add 5 to this position here at 3. So I can say, whatever's there at 3, add 5 to it. So I just went from 5 to 10. I changed the value here in the array. If I wanted to add two things together, so now I want to add this position, I want to add this index, the element in this index to this element at this index. I would say mylist at position 2 plus mylist at position 3, and set it to a variable sum. Notice it's 4 plus 10 is 14. So now I have a variable sum that's 14. And then lastly, if I want to access it so I can print it out, I will say here value at position 3 prints out 10. So this is just high level things you can do. You can get creative about how you specify the index. You can put a variable in the index, and we may go over that in a little bit. Array types. You can create arrays of primitives like what we did in our examples. So here we are creating integers. We can do booleans or doubles, whatever. They're primitives. And we can also create arrays of objects like string. Here I created an array of 51 strings, and I created my custom object. So here I created a custom object called car, and I wanted to create, and this is an array of 2 cars potentially. Notice whenever I use the new keyword and I'm creating a new array, I am specifying the number, the size. The sizes of new arrays are fixed, and this is a limitation of arrays. It's like you have to know how big these arrays are before you use them. So you specify that. You can't just say I want to create an array and then specify it later. Or if I go say I create an array of 10 values and I want to add 5 more to it, I can't do that. I need to create a whole new array. So once you create it new, it's fixed. The size is fixed. It can't be changed. Now here's a couple shortcuts. One of the things you notice, if I create a large array, in order for me to set up the values, it's pretty long. I have to say value at position 0 is this value, position 1, 2, 3, and if I have a long array, it could be a long setting it up. This is called an initializer list. You can do this for any type of array. And essentially, when you create, instead of using the new keyword and specify new int size 7, new int 7, I can specify, when I'm initializing it, this open and close curly braces and set the values in a comma delimited list. So here I'm creating an array of 1, 2, 3, 4, 5, 6, 7 integers, and I've already set the values for those integers. So position 0 is 1, position 1 is 5, position 2 is 68, and so on. I can do the same thing for objects. So here you can see I've created a list of array of 4 strings. And here I've created an array of 2 cars. So here you notice I'm creating a new car, a new yellow car, and a new blue car. So note, when I create this and I start it off, I can still change the values inside. I can change my mind, like say list. I want position 3 to be a beagle instead of dog. I can say your list open brace 3 close brace equals beagle, and it'll change. But what I can change the values inside the array, but what I can't do is change the size. Again, once I've created it here, I've now created a 4 element array. If I wanted to access element 10 of your list, it'll throw an error. So arrays behave very much like their individual counterparts. So if you remember primitives, so even though my list is an object and it points to a chunk of memory, all it is just a whole bunch of integers back to back. So I just hold the values of those integers in that array. So here my list at position 0, it's 1, 5, 68, and 24. Now with objects, it's very similar to variables, is that they are pointers to locations. So here, if I have a car list, I have 2 cars, one at address 175 and another one at address 294. The array is just those addresses back to back. So I have position 0, address 175, and the next position I have address 294. So you'll get to pointers. If you start digging deep, it starts getting with a lot of pointers, but you can see how it works. The car list is basically a whole bunch of memory addresses stacked back to back. Now here's another little shortcut, just like the initializer list. You'll find that you will have to loop a lot of times through arrays. You want to cover all the arrays starting from index 0 and going to the last position at n-1. So here, this is a for loop. You're familiar with for loops, but this is slightly different than the for loops you're used to. You're used to a 3-part for loop where there's you initialize something at this section, and in the middle section you keep looping while that's true, and that the last section is something that is executed at the end of the loop. For these enhanced for loops, it's a nice way to say for every item in that list, use this variable for that list. So I create a new variable s. In this example, I'm creating a new variable s and say for every variable s in this list, start it, and it'll loop through starting at position 0 and put the value of whatever is at the position into s. So you don't have to do any fancy work. So now in the exams and in the tests, there's going to be you probably will be challenged to not loop through all the items in the array. You may have to loop through only half of it, or when you're doing searching or sorting, you only want to hit certain pieces. So these loops, so this will not work for every situation. But for most situations, when you want to loop through every item in the list, this enhanced for loop is really handy. Next, object arrays do not automatically create new objects. So we saw in the first slide that when I created a new integer array, automatically the values are set to 0. Well, very similarly, when I create an object array, those values are set to null. So instead of, there's not like a 0, it doesn't actually create new car objects. So even though notice how I create a new car array, and I use the keyword new, but that new is just creating a new array object. It's not creating new car objects. So here I've created a new array of cars, but there's no cars in there. So if I start looping, if I don't set those values, if I start looping through it, I'll get a null pointer exception right here at line 9, because I'm trying to access, I created a new array with null values. It'll try to go to the first time through the loop, it'll try and go to this position. It says, oh, this is null, and I'm trying to get the function getColor from a non-existent object, and it will fail. If you create one of the other things that you'll hit a lot of times with arrays is bounds. So again, we said the positions of an array are from 0 to n-1. So if I create an array of n elements, in this case n is 10, then the positions are 0 to 9, 0 to n-1. 10 minus 1 is 9. So I can access my list 0 to my list 9. If I try and do something crazy like hit a position of a negative number or hit a position of 15 in this case, 15 doesn't exist in a 10 item array, 10 element array. So it will throw, you notice it's throwing an error at line 8 here in sample main at line 8. It's trying to access position 15, and you'll get this array index out of bounds exception. So keep that in mind for tests and exam. If I try and hit a position that doesn't exist in an array, I'll get the array index out of bounds exception. An array is an object, and because it's an object, it has one member you can use, and that's length. You can use this value at any time to determine how long the array is. Here you can see I've used the initializer list, and I've created an array of size of 7. And when I print it out, you see that prints out length of 7. Now, notice that this is slightly different than the string length. So string also has a function called length, but it's a function with parentheses around it. And an array is slightly different. This is not a function. Length is not a function. Length is a member variable, and so you call this without the parentheses. This gets kind of confusing, where strength has parentheses and an array doesn't. Here is the most common problem you will experience with arrays, and that's accessing a member of an array outside of the bounds, maybe in a poorly constructed loop. So let me give you an example. Here you can see a poorly constructed loop. I start at position 0, that's fine. Sometimes you'll start at position 1 and you'll be wondering why you missed the first line, so that would be another poorly constructed loop. As I loop through, I go to position 0 and print out hey. Then I go to the next position, index is 1, and I'm printing out you. Then I go to the next position, which is 2, print out guys. And then index will go to 3, and then right here index will be 3, and 3 is equal to the length, which is 3. So you'll think, hey, this is an array of 3. I can access position 3. So when I try to do that, I try to access position 3, it'll say, up, you're out of bounds, because really all you have access to is 0, 1, and 2. So this is a common issue. The issue is really with this, the equal sign right here. If I just made it less than, it would have been fine. But because I tried to get to that last one right after guys, it doesn't exist, and it'll give you it'll give you an array index out of bounds issue. Now, believe it or not, you've seen arrays before. Every function that you've written that has a main, every main function you've written has this parameter that's passed in called string args. And you may have wondered, why do I need this? Where does this come in handy? Well, way back in the day before graphical user interfaces, a lot of things were written command line. And Java has this. You can run your program via command line. That's really what's happening when you run it in your editor like JGrasp or Eclipse. Essentially what's doing behind the scenes is calling Java and the name of your class. When you call the name of your class, what the program does is it looks in your class for a function that's static void main, passing in an array of strings. So here you actually see I'm calling my class, and then I pass in a list of strings, so all separated by spaces. So I just say I have my first Kentucky home. And what Java will do is put these strings into a string array. And here you can see right here, I'm looping through that input array and printing it out. So you can see when I ran it from a command line, it printed out what I passed in. The first string in the array is my first. The next string is Kentucky, and the last one is home. So this kind of helps piece together what you've been doing since the beginning of the class. Why do we even have an array of strings passed in? And this is the reason why. So you can pass in different variables at runtime. So this is the dynamic part of a program. You can pass in different variables and get your program to do different things, and you don't have to hard code it into your code. This concludes the introduction to arrays. Thanks for watching.